Okay, so first things first, we're just gonna check if the beam expansion's on the right setting. It should be at between D1/2 and 1.5 for a magnification of 1. The laser is turned off currently, and you can tell by the green light being turned off. First, home everything. And to home everything really well, actually bring it down. 222. So, step size, let's go by tens. And here, positive means away from the lens, and negative means going up towards the lens. So we're gonna hit positive and a step size of 10. And that's moving now down 10. We'll go a bit lower. One more time. Go another time. So now we can safely remove this acetal so we can home it. Alright, close the sash back down. And now you want to home the Z first for safety reasons. So you're just going to click this button here to home. And then you can see it moving down. Now we're going to go do the same for the others. So let's do our X. You can see it's moving back. Let's do the Y now. All right. And then we can hit A. And B. Actually, B, we just go to 0B. And so if I say go to the reference point for A, and I'll go here. Nice. And then we can put this back on, the acetal plate. Make sure it doesn't touch. Cool. And all right. Okay. So now we can go to our Z0, or we can go from this to the reference point. So if I click go to here, it will move that arm up. Actually, is it close now? We can still go towards that. See, it's -52. Go to -56. Just have your hand on the stop sign, just in case. That's good. So we're a little bit off from our registered, our set 0. So now let's go to Y. Have your hand on it. And the same thing with X. And bring it out. So that's where we originally set. So that's where the reference points for the laser is. And then you can change this in your zeroing to match your codes. So what we can do now is check if our stage is level. Do that, putting this here. It looks okay, but slightly off. So we can play around a little bit. So we did figure out that it was 500 microns off, but we can play around with that. So if I go that, it's almost level. One more time, maybe one more time. So you see, you want that bubble in the middle. And that looks like it's level on the A. So what we can do now is zero this for A, and then we'll do the same thing for B. You can see it's slightly off. If you look for the bubble, let's do minus B. If you can see the bubble, we're moving away from it, so it should be B positive. Now let's try looking in this direction, maybe a little bit more. Looks like it's about in the middle. Maybe a little bit more. That looks good. And then we can zero the B here. Okay, so now what we want to do is move to the focal point, which is 49.7 millimeters below the lens. And we've already found before that the lens is at a Z value of 106.574. So what I will be doing now is the 106.574 minus 49.7. But now we have to take into account the thickness of our copper sheet, which I placed somewhere, and right here. And this has a thickness of 1.79 millimeters, so subtract 1.79. Oops. So 106.574 minus 49.7 minus 49.7 minus 1.79. So that will make the focal point the surface of this sheet. So it should be 55.084. So you want your Z here to be minus 55.084. So let's move up 1, which means it's actually going, the arm is going down away from the laser. So that's 55.606. And then let's keep going. 55.86. There we go. So that's what the number we want here, and that's the Z value from our previous. So it's how much off it is from our previous Z that we set 0. So I'm just going to zero this right here. And now we can play around a little bit. We can just move the X and Y a little bit around so we have some room. So I'm just going to move Y around to center. You can also set on continuous to 100% to move faster, and you can just hold this down now. So it's moving. I'll move out the X a little bit. So we're about center. Now we can zero both of these. Looks good. And then we're going to load our file. And what we did was a circle, which is 50 microns in diameter, and we're using a feed rate of 0.1 millimeters per minute. Select that. Let's load our plate somewhere around here. Should be flat. And then we turn the laser on. Now you can see the green light is on. And let's just test out to see if our laser turns on. So this machine is optimized for a 400 hertz pulse frequency. So let's go to 400. Laser on. Laser is right over here, right in the middle. Looks good. Turn off. We want our attenuation to be 0 for max power. So 0 is max, 4000 is off, essentially. What we can do is now check we're using a tool 1 for this path. So we go to configuration, macro list tool 1, and it says a pulse frequency of 410. We really want that to be 400 because that's our optimized. And to save this change, you click the download button. And this will record any changes. This save button is to save the whole configuration to the disk, whereas any changes to tool path need to be saved by clicking the download button. So now we can go back to operate. We've loaded our file right here. And that should be it. Now you just hit start and have your hand on the stop button just in case something goes wrong, and you can be there to stop it. We are going to be using a feed rate of 0.1. You can change this by overriding it. So if you do 50%, it'll be 50 microns per minute. So let's try with the 0.1 and see if that will work for this. And you hit start, hand on the stop, laser turns on. And you can see now these positions are moving with the codes at a speed of 0.1 millimeters per minute. And now we just wait.